love my kitty cat, I love you. I love my kitty cat, yes I do.
Nightmares creep while you and me repeat this bittersweet heat.
Hello guys, today we're going to work with limits at infinity, which means we're going to see what happens to a function when x is a very large positive or negative number. Let's start with the limit as x approaches to infinity for the function x squared. Basically, we're going to find out what happens to this function when x becomes larger and larger. Now, think in a really big number. You got it? Okay, now square it. How's the result? It is even larger than the first one, right? And this is something that is going to happen every single time. The larger the value of the x, the larger the value of the function. Therefore, we can say that the result of this limit is infinity. But what if we need to find the limit as x approaches to negative infinity for the function 2x squared? Well, let's insert the negative infinity into the function to find out what happens. Here I'm saying that I have a very large negative number, okay? And I'm going to square it. So my result is going to be a very humongous number, right? Because the rule of signs is being applied in this part. See? That's why I have a positive infinity in this part.
Diles, hola, toda la tortilla será la twilight bajo la lluvia. Silent Myers.
After that, I'm going to multiply my result by 2. What is going to be my result? Well, a very big, large, enormous number that we represent with infinity.
You know, because if we wouldn't have that kind of representation, we would run out of adjectives to describe the number, you know. That happens.
I almost forgot to write the infinity. You know, just the answer.
I knew it. This thing was not recording. Oh my.
Well, how about this limit? In this case, we have a very large negative number raised to the third power. The result, well, is another very large negative number, right? So we represent that with this negative infinity. In this case, we have a very interesting situation. Why? Because in this case, we are dividing a number by a very large value. See, in this case, we're finding the limit as x approaches to infinity for the function 2 over x squared, which means that we're going to plug in infinity every time that we find an x in this function. Basically, what we have here is 2 divided by a very large number. And this is equal to 0, right? But why the result of this limit is 0? Well, imagine that you're trying to share a cake. As the number of people who is going to receive a slice of the cake is increasing, the actual size of the slice of the cake is going to get shorter and shorter, which means it's going to get closer and closer to 0. That's why we have that the answer for this kind of limit is 0. Well, it's not like you're gonna get a slice of cake, but well, you get the idea, right? Please remember all the information that I just gave you, because you're gonna need it when you work with this kind of limits, okay? Well guys, in this case we have a very different situation. Why? Because if we just substitute infinity every time that I have an x in this function, my result is gonna be undefined. Just in this part. Right here, that's where we have the first problem. Because infinity to the second power multiplied by 4 is just infinity, right? And the result of negative 5 times infinity, well, that's negative infinity. You might think that the difference between these two is 0, right? Think again. Because infinity is not an actual number, it's just a representation, which means that we don't know which one of these two is bigger. Therefore, the result of this is undefined. Don't worry, I'm going to show you how to find the limit of this type of functions when x approaches to negative infinity or infinity. The first thing that we're going to do is to find the x in the function with the biggest exponent. In this case is x squared, right here. See? X squared. Then I'm going to divide each one of the terms of my function by this term, by x squared. Now I'm going to simplify my function. Well, after all this algebraic treatment, I'm going to determine the limit as x approaches to infinity of the function for minus 5 over x plus 3 over x squared. All this divided by 6 plus 3 over x plus 2 over x squared. To continue with this process, I'm going to substitute infinity each time that I have an x in this function. So in this part of the process, I just substitute infinity every time that I found an x in my function. That's why I have 4 minus 5 over infinity plus 3 over infinity squared divided by 6 plus 3 over infinity plus 2 over infinity squared. Well, do you remember the information that I just gave you a few minutes ago or seconds? I can't remember right now. The thing is, every time that you have a number divided by infinity, the result of that operation is going to be 0. That's why instead of having negative 5 over infinity, you have 0 because the result of this operation is 0, right? And instead of having 3 over infinity squared, you have 0 because in the end, infinity to the second power is again infinity. And 3 divided by infinity, well, that's 0 too. For the denominator, 3 divided by infinity is also 0. And it's the same thing with this 2 divided by infinity to the second power. That's also equal to 0. In the case of the 4 and the 6, we know that the limit of a constant is the same constant. That's why I didn't change the 4 and the 6. So the result of all this is just 4/6, which is equivalent to 2/3. That's my answer, guys.
And the actual answer of the problem.
Next exercise, we're going to find the limit as x approaches to infinity for the function the square root of 16 times x squared minus 8 divided by 2 times x plus 3. So the first thing that we're going to do is to find the x with the biggest exponent. Be really careful with this x squared. Why? Because it's inside of a square root, meaning that this is just an actual x, which, by the way, is the term that we're going to use for this exercise. Well, I just divided each part of the function by x, but we have a problem right here because I need to get this x inside of the square root. The thing is, to keep this function unaltered, I need to get the x inside of the square root in a way that when we calculate its square root, we obtain the same x. See, I have a division by x squared in this part of the function because if I calculate the square root of x squared, I'm going to obtain the same thing that I have right here. Also, I just simplified the denominator of my limit. See, 2x divided by x, well, that's the same thing as 2. 3 divided by x, well, I can't simplify that, so I'm just going to copy this term to the next part of the limit in the same way. Now, let's continue with the process. I'm going to simplify this part of the function.
Taxas de perico, taxas. No usan taxas de perico.
To simplify this part, I just split the fraction in 2 parts to cancel out this 2. This was meant to be squared. Okay, this 2x squared. So all the rest of the elements are going to be copied just in the same way because we're not going to alter anything in them. After this, I just need to substitute the infinity every time that I have an x in my function. That's what I have, the square root of 16 minus 8 over infinity to the second power divided by 2 plus 3 over infinity.
No, Aquí está la monetización. Ah, espera, no tengo monetizados los videos. Ah, qué caray.
Moving on to the next part of the problem. So this is the result of my substitution, right? I just change every x by infinity. Let's analyze the results of all these operations. So far we know that the limit of a constant is the same constant. That's why I have a 16 here and this 2. Because 16 and 2, they don't have an x to substitute the infinity. They are going to continue unaltered. That's not the same case with this term and this other one. We know for a fact that the result of this operation is 0. Why? Because infinity to the second power, well, that's just infinity again. And 8 divided by infinity, well, that's 0. It's the same thing with this 3. 3 divided by infinity, well, again, we have a 0. Therefore, we're going to calculate the square root of 16 minus 0.
The cat is biting me. Tell them I'm biting my human.
Therefore, the result of this operation is just the square root of 16, which is the same as just 4. In the case of the denominator, we have 2 plus 0, that's just 2. And 4 divided by 2 is equal to 2.
Equal to 2. 2, 2, 2, 2, 2, 2.
Yeah.
It's equal to just 2. So the answer for this limit is 2. Thank you so much for watching this video. Please do all the stuff that you're supposed to do when you like a video like this. You know, they like and subscribe, all that stuff, you know. And say goodbye to everybody, Twilight. Bye, humans. Bye, humans. You smell like roaches.